So the government is still all about buying hardware, vertically integrated hardware. Let's simplify it. I'm going to give you the check. You find your suppliers and do your thing. That's still the de facto way that they buy capability. That fundamentally has to change.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year. But so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now, I'm Noah Scheinbaum, and this is Crossing the Valley.
Applied Intuition is a leading player in vehicular automation. But unlike many of the other big players, they're not building vehicles. In fact, Applied is 100% focused on software. At Manifest Demo Day in DC, I caught up with Jason Brown, or JoBu as he was affectionately known throughout the Air Force, who's one of the driving forces of defense innovation and has been over the last decade. He served for 26 years in the Air Force. He commanded the 480th Intelligence, Surveillance, and Reconnaissance Wing, which is responsible for the DCGS weapon system, and he was behind many Air Force software modernization efforts. JoBu also founded the Air Force AI Accelerator at MIT, and then he went on to lead Google's professional services business for defense. Today, he's the general manager for Applied Intuition's defense business. And Jason is still obsessed with the role of software and the role of data in the future of defense, because he's seen its impact firsthand. In our conversation, we talk about the company building the future of automation, how far the department has come, and what is next for software and data in the world of defense. Enjoy.
All right. We're here with Colonel Jason Brown, JoBu, one of the original defense innovators here at Manifest Demo Day. Man, you've been from the inside to the outside, from the 480th to Google Public Sector, now at Applied Intuition. It's you have kind of a knack for showing up at the right place at the right time in the defense innovation world, Jason. How has that been the case for you over the last decade?
First of all, thanks for having me. This is really, really awesome. This is a great event that we're at today, and a lot of old friends here, which is, to your point, like you see a lot of the same players who have been like slogging it out in this whole ecosystem now for several years. We got more events this week, actually, where I'm sure I'll see a bunch more. Right place at the right time. I think everything started for me back when I was a group commander, actually, in Germany, like 2015 timeframe. Right around that time, there was kind of this, Ash Carter was starting to awaken the Department of Defense to how behind the DoD was with its relationship to Silicon Valley. And all of this was happening at a time where you started to actually see, like in my case, airmen, like actually using software to solve real problems in ways that no one trained them to do. No one told them to do, but they found a way to hack the system. In my case, ISR operations, intelligence, surveillance, reconnaissance operations, they were coming up literally with Python scripts and integrating data in ways. I don't know how they did. I didn't ask too many questions. They just did it. My world opened up because they're like, "Hey, sir, check this out." Like, we were looking for this stuff over here. These particular, in this case, a Syria no-fly zone is what we were planning for back in 2014. 2013, before ISIS became a thing, and we had to solve the problem of that by locating these Russian, surface air missile systems. They found innovative ways to use software and data to do it in ways that I, as an intelligence professional, had never seen before. And I realized that it all became, for me, how do I make this happen at scale all the time? And that is what I just became passionate about, started writing about, starting to find a community around doing different aspects of this throughout the military. And then when you start really engaging, all of a sudden, you're talking to people in the Defense Entrepreneurs Forum. You're going to Silicon Valley. People back then, we got very involved with Project Maven. Our wing was like one of the first customers for Project Maven. Drew Kukor and I were in like Silicon Valley in 2017 talking to people, and they're like, who are you? Like, why does the Defense Department here? It's very interesting like fast forward to today, just kind of the sea change. And then just, so there's been others who have just carried the mantle. It's been really awesome to see.
People think about DoD and bureaucracy as these slow moving things. The reality is a lot of this has happened in the last 5 to 7 years. This hasn't been, there are things that started decades ago, but this event we're at right now, if you had this 5 years ago, we have 1,000 people here today. There would not have been 1,000 people. There certainly wouldn't be 35 defense tech companies demoing on stage. You wouldn't have PEOs from across the Joint Force showing up to take these demos. And, when you talk about something like Maven, we actually had Emmy Probesco up from CSET came on and did, they put out a pretty cool case study on the implications of Maven, some of the impact that it's had. And Maven was declared dead how many times over the last 10 years?
Yeah.
You went to Google in the public sector business. Famously, the Google memo of the engineers revolting against Maven was kind of in many ways the catalyst to the modern defense tech movement, I think. So it's fun. This actually moved pretty quickly, all things considered.
I think so. But, there's parts of it that have moved quickly. The community has grown very quickly. The investments, at least from the private sector, venture capital in particular, have happened fairly quickly. In many cases, there have been contracts that have been really mounting, like just increasing, giving the opportunity to Silicon Valley companies. Honestly, Palantir paved the way in a number of different ways. Part of that also had to involve actually suing the government to give them a fair shake. And they're, not the only ones who had to do that. But over the course of time, there's been a large swelling of just people who are like-minded, who know that we are going to ultimately compete with China around this very problem that we're trying to address, which is defense tech innovation. They have this advantage of all the IP in China by any Chinese company goes to the military, goes to the government. That's not our system, nor should it be, right?
Yeah.
But we have to find a mechanism to ensure that the very best technology gets in the hands of the warfighter. And the thing that doesn't prevent them from obtaining it is some ridiculous bureaucratic practice, culture, process, rules, constraints. You see it all the time. And certainly not the same players, right? I could go on and on about that. There's a lot that's changed. There's a lot of room to grow, a lot of things that we still got to do.
So DoD is crossing its own valley of death, maybe in tech adoption here. We see crossing the valley is deliberately vague. It's meant to mean everybody can see what they need in that. There are many valleys that need to be crossed, and even we know on the tech adoption standpoint, it's not just one. I want to talk a little bit about you, and then we'll talk about applied intuition and the company and the technology.
Sure.
I think it's really instructive that from where you were at the time you were there on the inside when you were still in service, as you were getting out, you didn't go to a large traditional prime, but you also didn't go to the Series A startup. You landed it at Google, which like we said already, has been kind of at the center of this controversy over the years of, is this a commercial company? Is this an American company? What does that mean in terms of their obligations to the country? And I'm curious to just hear your thought process in that decision of how you thought about the type of company that you wanted to go to and how you wanted your contributions to continue as you transitioned out of service.
Yeah, Drew Kukor and I pitched, interestingly, when I was still in uniform, we pitched Google on Project Maven. So it was at CVPR in 2017 in Honolulu that year. Jack Shanahan was there. He famously was the leader of Project Maven, and then later the first director of the Joint AI Center, of which I helped stand up. But we went to pitch Google specifically on this capability around Gorgon Stair, which was this high definition, you could see 8 kilometers over. In this case, we were looking at Mosul, Iraq, and in high def. And then I had 10 airmen at Beale Air Force Base who were basically looking through soda straw views. And they could only see 10 different compounds, 10 different areas of interest. And there was all this other data that was falling on the floor. What if a computer vision algorithm could actually track vehicles, between these compounds? Where did they go that's new? Where did they come from? When an explosion, happened from a vehicle-borne explosive device? This is what we're fundamentally trying to track. ISIS was using Mosul as the staging ground for all of this. killing hundreds of people each time that they would blow one of these up. This was a compelling problem we brought to Google. And then Google, immediately said, this is like, literally there was, some senior engineers at Google who said, this is the hardest computer vision problem we've ever seen. And they were hooked. And it was about solving that mission. And during the time that we actually worked with Google, before the famous sort of, where they famously did not renew the contract, my airmen went to Mountain View. Google engineers came to see my airmen at Beale Air Force Base, and they felt like they were part of the product team. My airmen did. It was an experience that was far different than anything else I had seen with any other vendor, right? Certainly with a government lab, et cetera. Like, that was what, to me, was what right looked like. And I recognized that was a Silicon Valley way of doing it. It wasn't just Google. So when I had this opportunity, when I retired, a couple of years later, I had the, conversation with Google, and I knew that Google wanted to get back into defense in a very serious way. And I saw an opportunity to get what I had experienced as a Google customer and then bring that back to defense. Yep. You fast forward to today, speaking of Google, I mean, clearly they're all in on defense, and they recently revised their AI ethics and principles to demonstrate that. And so we've come a long way with the Silicon Valley relationship with defense. It's very encouraging to see. That's the direction I wanted to go. The reason I left the military was fundamentally I wanted to go faster, right? I knew we had to go faster. Going back to that story I told of like working with those airmen, I did that time and time again, but we'd always hit a roadblock, and it would always be something that slowed them down. It was always the bureaucracy. Yeah. And I knew that even if I stayed and, made, multiple ranks, above colonel, I wasn't going to be able to go faster. Like, that bureaucracy could only be affected from the outside, and it could only be affected by the right companies getting engaged.
There's something to be said here, and we'll talk about applied intuition in a second, but the right companies is I think a really interesting point to make, which is, I'm kind of like this. There's people who love the 0 to 1, the kind of that initial discovery period. But the reality is most of the gains, and we'll talk about generative AI as well, most of the gains accrue to a few players. And those are the ones who are in a position to impact missions at scale. Google's certainly one of those players. Applied Intuition in the autonomy space, you could say the same thing. They are if not the market leader, not, the company that's kind of like, hey, we want to do this kind of very niche autonomy for this one very specific mission. And so I think that's a consistent thread and kind of in the decisions you've made. So maybe play that forward. You, I think, achieved many of your goals in your time at Google. I don't want to overstep. You can tell me if you did.
Yeah.
And then have kind of taken on this next mission. So what was the transition to Applied Intuition all about?
The opportunity came up. We had, had this, someone reach out to me and had some conversations about Applied and the technology, but there was clearly a recognition of where they sat in the autonomy space from a dual use perspective. And the more I've learned and thought and really studied all the aspects of autonomy, what that means, that word, right? I realized that we are on the ground floor of a capability that is both dual use in nature. The nature of autonomy is dual use. The way things go with regard to the technology being developed in the commercial space will influence the defense space and vice versa. I'll give you a quick example of the vice versa, which is non-intuitive. Things that we at Applied have developed for the Army, right? Off-road autonomy has found its way back into our construction, mining, and agriculture business, right? It's off-road autonomy that was developed specifically for the Army. That will be the case with the maritime autonomy that we're building now, the collaborative autonomy, the aviation autonomy. All of that is going to be primarily funded and initiated by the military that will feed its way back into our commercial business. The flywheel is really important. But Applied had this incredible, set of customers with the commercial automotive, OEMs. And the maturity of that technology, all of those OEMs, by the way, all recognize they have to compete with Tesla, right? Tesla is famously vertically integrated. You have to build what is now known as a software-defined vehicle. And doing that is something that the OEMs recognize they're not really good at. They definitely have great software engineers and but not a lot of them, not to the degree that they need to fundamentally scale their capability to be competitive in that market, right?
Yep.
So that's where Applied really met its value proposition, and it's very transferable, as you can imagine, over to defense. And so the challenge, of course, is it's a different set of rules, different set of kind of governing principles in many ways with, defense OEMs and, the way that the government regulates and does some other things. We can get into that, certainly. But for me, it became, I'm an operator at my core. I've spent 26 years as an operator in the Air Force. I understand when I see a technology that is fundamentally going to benefit the operators. That is exactly what autonomy technology is, not just vehicle by vehicle, but how do they collaborate? It gets back to this idea, right? Expanding that out, that, the many and the small always defeat the few and the exquisite if the many and the small are effectively networked. And unpacking that term, effectively networked, is one of the things that we're doing now at Applied. And so all of this kind of gets back into like military theory and very tactical in nature and OODA loops and all that stuff, right? And so being able to get to that level with Applied and our technology was super appealing to me.
Yeah, I want to dive into the effectively networked piece before we move off it, though, because I think you said something that the parallel is almost hits you in the face. The way that the commercial OEMs recognize, the Fords, the GMs of the world said, hey, we're not actually software companies. We're going to have to partner to be competitive in this space. Arguably, that same recognition in the defense space, right? The legacy primes. Do you think they've had that recognition of, we're not software companies or we're not modern technology companies? Or is there actually more resistance in the defense space than what you're seeing commercially?
100% more resistance. There is definitely an example or two where I could point to a specific defense prime here and there, and they clearly understand that they need software partners. By and large, they treat software as a cost center, not a core capability. And we have more software engineers at Applied than all of those defense primes do individually as companies, right? And we have 1,000 people at Applied, and we have more software engineers than pick your defense prime. And so the challenge they face is not just internally and the way that they're structured and the way that they have and their own internal culture and incentives. It's also the constraints that the government puts on them. Mm-hmm. So the government is still all about buying hardware, vertically integrated hardware. Let's simplify it. I'm going to give you the check. You find your suppliers and do your thing. That's still the de facto way that they buy capability.
Yep. That
fundamentally has to change. So you've got at least a sign it's changing with the software pathways memo that Secretary Hegseth just published. We have got to see how that's going to be enforced. We've got to see how the services, DIU, by the way, can't do all the software contracts for the Department of Defense. The services each have to figure out how they're going to, conduct commercial solutions opening. And, other transaction authorities, they have to do it program by program. Yeah. They have to have direct relationships with software companies. And let me make something, I guess, super clear. When I say software companies, I mean product companies. Software companies who know how to build a product and how to scale a product to go from 10 users to 100 to 1,000 to tens of thousands of users. That is a very specific skill set of a product company, not of an engineering services company, right, of which many of the government program offices will say, I'm working with commercial, I'm working with, technology companies, and they're working with engineering services companies that don't know how to scale a product to the degree that the DoD needs.
So let's double tap on that one and then move back to Applied. Was there enough in the software acquisition pathways memo that you referenced? Do you think there's enough in there just saying, hey, OTA is the default, contract? Is there enough in there to get away from the services firms, or is that still going to be the loophole that you think many of these folks are going to use?
So I think there's enough in there to make it very clear of what they should be doing. I think there are going to be undoubtedly some very specific programs that the Fourth Estate, in the building, they call it the third floor, right? The Office of the Secretary of Defense is going to be very laser focused on to see how the services specifically behave based on the memo.
Yeah.
And so a lot of acquisition approaches that were already underway or about to be underway related to those specific, very heavy software programs are going to have to be reconfigured, and the DoD is going to, like, the OSC is going to have to, like, enforce it, and I'm sure they will.
Yeah.
However, there are just countless programs that have software as a core component to the capability that may just not, it may fly under the radar. They don't know how to actually work through it. You have program offices who are visionary. There's not enough of them. People who have the confidence that they can have a separate contract for a software vendor and software vendors, plural, and a hardware vendor, and be able to technically program manage, like, among those two. Those program offices are few and far between, but every single software is going to be everywhere for every program, and you've got to figure out how to do that. If you continue to work through the system of, give it to a vertically integrated, solution to a prime contractor, you're just going to kind of get more of the same. And then the other challenge, of course, is the accounting system for the government is, even if a prime contractor wants to have enterprise services that are software based, that each of their programs, let's say they have different ground combat vehicles among their portfolio, the government will say, well, you're charging me for this operating system that you're using across all of these programs, but I don't know how to account for that, so you're not allowed to use it, right? There's a lot of constraints that the governments themselves put on because they want to keep the accounting clean.
Right.
Everything's stovepiped into a program element. Everything, and then just software, just the nature of it doesn't work that way. Yeah. They got to figure that part out.
So a very good starting point, some strategic kind of guidance that is quite clear. Devil's in the details. Implementation is going to continue to be a challenge, and there's likely going to still be some churn is kind of what I'm hearing.
Absolutely. I think DIU hopefully does not itself become overly bureaucratic. It's an amazing organization, and thank God that they exist. Thank God they've, elevated in stature under the last administration, will continue to. It appears under this current one. I just hope that the weight of all the things that we need done doesn't fall on their shoulders, that the services fundamentally figure it out.
Got to protect DIU. Yeah, no, I think that's a good kind of place to leave this portion of the discussion, because I do want to get into applied as well. I think you said a number of things up front, including all of the different kind of pathways to market for the company in the earliest days. Autonomy is an interesting one because it's been a conversation that's been there for a while. In talking before, you kind of said, look, ground or vehicular autonomy is kind of a solved problem. And in some ways, yes, Waymo is slowly starting to roll out across the country. But we've also been hearing about it for 5 or 10 years. And the truth is, when we leave here today, we're going to call Ubers, not Waymos. There's going to be a human driver, not a machine driving the car, at least here in Washington, D.C. So I'm curious, let's start with just kind of the story of Applied's early days and kind of how the company has managed to build up to the point where, now it's the market leader. Series E, I believe, was the last round of funding raise. Where did it kind of start in terms of proving out the value of this technology in a way that generated trust?
With the commercial OEMs, as I mentioned before, they all recognized they had to compete with Tesla, of course. They knew that they had to up their game from a software perspective. Tesla was doing something incredibly impressive with regard to some levels of autonomous driving, right? And driver assistance. And so the development of that software is really challenging. So just to kind of break autonomy down, right? It's really about perception, planning, and control. Individually as vehicles, and then we can get into like collaborative autonomy when you're doing that as a swarm, especially on the defense side. But perception, planning, and control, and that it all starts with perception, and then building tools to adequately. And this is an AI problem, of course. This is computer vision, and nowadays it actually expands into generative AI, which we can talk about as well. But you get into the perception part of this challenge. And so what that means is you need to fundamentally create a simulation environment, because live testing is super expensive and it's super slow. You need to create a simulation environment, which means you need to have adequately represented from a physics-based modeling the sensors the vehicles, the objects within that environment, the environment itself, and the dynamics in between them need to behave exactly like they would in the real world. And then you run those and that's an engineering, the massive engineering challenge, which, by the way, your OEMs are not going to solve on their own, right? That's a massive challenge for them to invest in. And why would they if you could provide that, solution for them? But once you get that simulation environment down, and which is, what the company focused on heavily on the tools at first. And so the tools being, how you develop autonomy software with these specific, very sophisticated tools. Simulation, synthetic data, recreating anything synthetically, digital twinning every aspect of the world, and then fundamentally running those simulations, exposing the failure modes, seeing when the software fundamentally fails, starting with perception, later in planning and control of the vehicle, and then noting when you have those failure modes exposed, how do you then say, okay, when the sensors and the vehicles in this scenario continue to fail, the perception is degraded for whatever reason. Show me all the examples of where we've seen that scenario within the large corpus of data of live and virtual testing. Bring that forward, use that as a new training data set. And that's a very sophisticated set of data management tools. We call it a data engine, right? And so you're able to bring that forward. This all has to be done within minutes, not like hours and days. You're not like going through, you have to be able to do that in minutes. And then you're able to create a new training data set. You're able to recreate it from a synthetic perspective. So you have even additional examples of that scenario that causes a failure mode. And nowadays you even get into like generative AI of manipulating, all of that training data, add smoke, add fire, add whatever you want.
Yeah.
And then now you're able to make those models much more performant, much more quickly. So that's fundamentally that core piece of technology is where Applied started and continues to be industry leading in that whole area. You can imagine all of that. And by the way, today we demonstrated two different products. One was called Maritime Sim, one's called Mission Sim. Maritime Sim, just like it sounds, doing exactly what I described, but on the water. And being able to replicate all the aspects of being a sensor on the water, salt, like sea spray and all the other glint from the sun on the water. And then Mission Sim is essentially swarms of robots, unmanned systems that each have their own autonomy, stack inside of it, all behaving in a certain way and being able to simulate that all in a physics-based environment. Yeah. Those two products themselves were created. Each was created from zero to actual first version of the product in 5 weeks.
5 weeks.
5 weeks. So the reason why we were able to do that is because we have this foundation of commercial technology that we just built on top of.
Yeah.
And so we've never done a maritime sim before, but all of the same technology approaches that we took, and we were able to do it. And so that's kind of where we started. And then since then we've gotten into the actual guts of vehicles themselves, the architectures, the operating systems, each of these software defined vehicles, whether they are built that way from the beginning or they're enhanced later, retrofitted. In some cases, you need to jailbreak them. You actually have to modify and enhance the architecture to ensure that you can put modular software capabilities on top of it. Modular software capabilities related to autonomy with human-machine interface, with whatever you might need to make a system, to make a vehicle more, in the case of defense, mobile, defendable, survivable, lethal, etc. All of these are software improvements that some of these vehicles just need to be retrofitted to enhance, and then others, those in development, you can tackle those from the very beginning. So the company's gone that way. I mentioned Porsche earlier. Porsche is a big company of ours. We basically build the operating system for Porsche vehicles. That allows for so abstracting all those lower level components, and then actually putting all the software stacks that are very modular on top. And then you can get this iterative DevSecOps for vehicles. Yeah. And that's what you have to do. You can't have testing go out to the old way of I'm going to test and evaluate, run it on a range, do all these things, and then come back with all these discrepancies. You cannot do that anymore. And you certainly can't do that with fully autonomous vehicles.
Yeah, I mean, it's remarkable. My first thought was like, well, 5 weeks first sounds really fast. And I was like, well, maybe it's just a one-shot prompt in an O1 or in the latest reasoning model that can generate these testing environments. Obviously not there yet. I think there's, a couple layers to what you're talking about here. The comparison to me in the Gen AI side is like what Scale and these other labeling companies provided. And right in the early days of Maven and the Jake and others, it was like, hey, we have all this data. We need to label it, whether it's whatever the type of imagery is, whatever the type of input is. We got to figure out what it is so that we can use it to train. And it sounds like kind of the way Applied has approached this is like, let's build the simulation engine that allows us to train those operating systems or develop those operating systems, regardless of the operating environment or the domains, whether it's air, it's sea or land or what have you. And so, the next question becomes, well, okay, what happens when you do train it and then the thing is out there in the wild? Like, what is the utility or the kind of the long tail of utility of that training platform, of that simulation engine? Or does Applied's business model shift once these capabilities are actually fielded?
It's a great question. So the first thing is we always integrate live testing to some degree. You always still need live data into all of that, into all of that workflow that enables you to make those models associated with perception, planning, and control more performant. We don't do anything or advocate for anything to be 100% simulated or 100% synthetic for a number of different reasons. However, increasingly, we continue to see models being really performant when trained with large amounts of simulated and or synthetic data. And it's just one of these things where you have to do it. You have to have that environment to be able to fundamentally ensure that your software remains performant. When all of these systems go out into the wild, we view this kind of operating system that I described before as part of a vehicle. It's not just on board the vehicle. It's also off board the vehicle. There's like a vehicle cloud architecture that exists that we fundamentally provide our customers that enables all of these different, data related to vehicle behaviors, components of the vehicles and how they're behaving, and all of that data flows back into this vehicle cloud. We call it an off-board platform. It's connected, not necessarily continuously, but at various different stages. So you can manage not just a single vehicle, but the fleet. That's the whole core of like DevSecOps with vehicles, is you need to get that data into that workflow. And so you have to view it as far as part of, how do I ensure that this vehicle's data, which is valuable to ensure that you're looking at various different ways that particular vehicle's function, but also the fleet, all makes it back. The challenge, of course, is in defense use cases is the reliability of connection. You just have to figure out, and this is one of the things that the Department of Defense fundamentally, and one of the things that I'm excited about are these ideas of like transformation and contact units that the Army's starting, and kind of going back to that, get the actual tacticians and the operators involved. Back to my airmen back in 2015. Yeah. They're going to know how these things are behaving, get them part of the process. The reality is this idea that any vehicle is going to be perpetually disconnected is completely unrealistic, because the military does not believe that you're going to be perpetually disconnected from logistics. They never plan for that. They never plan for, I'll never be able to refuel you. I'll never be able to, feed you again. I'll never be able to evacuate your wounded. True. It's the same thing with data. Like, yes, it's not going to be perpetual, but you have to plan for that. You have to plan for, how am I going to make the connection back into this cloud environment that I'm able to ensure that we're fundamentally updating that software.
Yeah. So it's that continuous piece. That's a really interesting point of, because we talk about disconnected a lot, but it's, if you don't assume that touch point, then the system can't update. You made the point earlier about, well, the networking piece is where this really starts to come together. And so there's kind of like the individual unit autonomy, and then there's this kind of collective or the collective or this swarm autonomy. I guess first, let's do one thing at a time. First, how many different vehicles, different platforms is Applied supporting today? Like, across the enterprise.
We, back in middle December, we announced it just recently, not too long ago, but we acquired a company called Episci. So Episci was doing, and we obviously were tracking Episci very closely, very familiar with them. I had a connection with Dan Javorcik. His call sign's Animal. Dan, he is a fighter pilot, like PhD in physics. Like, he was the guy responsible for the Alpha dogfight that DARPA put on, right? Human versus AI fighter pilot. And so we made that connection. It made all the sense in the world to go through that acquisition. Episci was doing essentially all the things that we weren't in the defense space from a aerial, space, maritime, and RF spectrum perspective with regard to autonomy.
Yeah.
They're conducting a number of really interesting, experiments for a specific customer around swarming autonomy. We're doing a lot of work with collaborative autonomy. That whole, both the maritime sim and the mission sim products that we demonstrated today, basically our internal customer is Episci. And so all of these engineers who are at Episci building autonomy behaviors related to swarming and related to maritime, uncrewed surface vessels, are working with our simulation teams, of which most of them never had a security clearance before. Now they all do, right? They were working on, commercial automotive things. And now they are like connected together, making each other's product better. It's really cool to see. That's the wonderful thing of like watching dual use like come together. So we're working in all of those domains. We're working with various different groups of UASs. We're working with manned aircraft. We're working with ground vehicles. We're working with maritime vehicles, autonomy behaviors, various different aspects of that kind of operating system that we're integrating. We're working with, we've got something brewing that will take us in a very big way in the maritime direction. I'll just leave it at that. Cool. And then the RF spectrum, which, getting back to your question about what does effectively network mean? People don't really think about or appreciate the domain of the RF spectrum to the degree that they should, right? So the RF spectrum, as we well know in Ukraine, is just like jammed, inaccessible in many ways. How do you cope with that? That is an autonomy or an AI problem, in the sense that if I need to reliably get my ones and zeros transmitted and effectively received, that is a learning algorithm that needs to understand the environment from an RF perspective and an electronic warfare perspective that currently exists, and figure out a way to get those ones and zeros, and the right ones and zeros, meaning what is the actual packets of information I need to transmit, and then do that very efficiently. That is an autonomy problem. Reversing that is when you have very intelligent, software-defined radios in the form of a radar that is tied to a surface-to-air missile system or another threat. They're bouncing around doing some very interesting things in a war reserve mode that you may never have seen before. It's an autonomy problem to understand that that is a threat that you're experiencing, not some new, novel sort of thing. And so that effective networking comes down to the way that the swarm actually collaborates and is able to change based on purpose, intent, and constraints. We get back again to military theory. This is a mission command problem, right? Purpose, intent, constraints. Go do your thing, swarm. That depends on the swarm actually communicating and connecting. And when some of it attrits, some aspect of that environment changes, it works within that purpose, intent, and constraints. So that whole set of technologies, we're doing that for all of those domains, ground, air, sea. We'll be integrating space soon. It's really cool.
Wow. It's all over the place. And then as you start talking about, okay, how do these things make decisions and what are the option sets and if this, then that, I imagine that's where the generative AI stuff starts to come into play as well. When you start thinking about the kind of the COAs that can be developed or the option sets available to these different swarms.
Yeah, there's an aspect of generative AI to apply there. There's an aspect of generative AI to apply in all sorts of places with regard to integrating with those very sophisticated tools I described as co-pilots. Yeah. So basically every software product seems to have a generative AI co-pilot. We are no different.
Yeah.
Interestingly enough, though, interacting with a autonomous vehicle or a swarm of autonomous vehicles can become a generative AI, interface. One of the challenges, though, is, I don't think there's enough investment in that space or really understanding. A lot of the DoD tends to be kind of liquored up on LLMs right now. And so if you think about this, right? If you think about where all the people who are buying AI right now, by the way, we talked earlier about the trajectory of where things have gone. Like 2017, it's like me, Drew Kukor, like a handful of us were running around the Pentagon talking about AI, and everybody's looking at us like a pig looking at a wristwatch, right? And so we were running around and we're just like, hey, this is really important. Like, pay attention. Yeah. And now everyone's talking about AI, but now they're talking about generative AI. Yeah. And they're not remembering that there's so many other components to AI that, quite honestly, are what they should be investing in right now and at scale in ways that they're not. And
we're a little slow. We got the crypto people running around.
Well, yeah. So, okay, not to take anything away from LLMs or their importance or their potential. But the challenge is that all those LLMs need to be trained on data that the Department of Defense to do the kinds of things that they're dreaming of. So kind of back to why are they investing so much in LLMs right now? Because those who are investing their recent experiences in an operations center, making resource allocation decisions under the form of command and control. Yep. And so they're like, okay, I wanted to make the fastest, most optimal decision, the best quality decision, and I struggled with information to make that decision. Could not an LLM help me? Intuitively, you would say it would make sense, but you still have to train it. And, I had this conversation at one of the CoComs the other day, and I said, look, any AI conversation always should start with data, a conversation about data. Yeah. Talk about the data that you're going to use to train that LLM to make that resource allocation decision. Yep. Do you have data coming from the edge? And they were like, well, what's the edge? And I said, the edge is the resources that you need to allocate or the resources that you depend on to fundamental supply chain, whatever it might be, logistics, to make that decision. Are you getting the data into an LLM in a training mode to be able to do that? And the answer is no, because if you think about all the data problems that exist in the Department of Defense, the access problems, the fact that even if the data exists, it's not in a readiness state, it's not accessible.
You think, is that the biggest? Is the access problem the biggest at this point?
It's 100% the access problem. So there's a whole conversation to be had about, this is some of the work I did at Google about APIs and implementing a data mesh, architecture, et cetera. That still has to be done. But my concern is that there may be an over investment in LLM related operational level of war, strategic, level of war focus at the expense of the very tactical, edge, autonomy capabilities that have to be invested in right now.
Workflow automation, the real simple stuff of let's just make people's jobs easier. Let's let machines do the things that they can do so people do the things that only they can do. I think it's a fair point. The other thing that you said earlier was when this stuff started happening, when you were, your airmen were the ones kind of determining what was, or they were bringing you stuff and being like, hey, sir, look what I built. I think the same is going to be true here, right? If it's the generals trying to solve this problem, it's great that they care, but they're probably not the ones coming up with the use cases.
That's right.
And I think the DHS AI core, which I don't know if it's still around now, but I think they had this kind of right, which was we're not just going to focus on policy and regulation. We're going to focus on use cases, and we're going to clear the policy and regulation to allow the experimentation at the lowest levels, the people who are actually doing the work, who have the line item responsibilities. And if you can't do that bottom-up experimentation, by the way, this is not unique to the government. This is the same way the large consulting firms are dealing with this now, the same way that large technology companies are dealing with this now. If you're so concerned about your data, don't feed it to the LLM, you're not going to get any of the gains from experimentation. Right. It really can only occur at those not the lowest necessarily, but at those lower levels, the people who are actually doing the work. So I know that's taken us a bit down an LLM rabbit hole, but I think your point is well taken. LLMs are not the be-all, end-all of automation. They're not the be-all, end-all of autonomy, and they're certainly not the be-all, end-all of artificial intelligence. So it's just one tool that we have that we should explore more fully.
Yeah, I mean, look, the thing that really concerns me is that we're very in tune with the commercial automotive sector globally. As you can imagine, in our company, we pay very close attention to what's happening in China with regard to EVs, autonomy associated with operating those EVs. they are remarkable. They are beyond beyond the capabilities of any Tesla. I mean, you're literally like stepping out of the vehicle, using an app on your phone to send your car 5 levels down in a parking garage to park itself. That exists today. You can buy that vehicle today. And so all of these capabilities that are, and by the way, like the Chinese have 20% unemployment among engineers. So if you have a job, you are working 18 hours a day to keep it. You've got 150 car companies in China. Again, a lot of industrial policy to focus on that. 18 major. They are innovating. They are innovating in very unique ways. And what really frustrates me is I keep running into people like this, not so much in like Indo-PACOM, but certainly in the building, in the Pentagon, where they don't believe that China is anything more than just copycats.
Yeah.
And that is a dangerous way to think about this problem. All of that technology, again, the nature of autonomy is dual use. If that's true for us, it's true for China. And so, intelligence swarms, and we talk about like Taiwan and, the challenge there, intelligence swarms of capabilities that, are effectively networked are going to be a capability that may be the winning capability. And so multi-domain, you can go on and on about what that looks like. At the core of it is getting software right, like figuring out how to interface with companies represented here and in the many sort of innovation venues that we keep finding ourselves. We still have to figure out how do you actually like work with these companies? How do you, fundamentally get them on contract, get them to bring you capability, and then just, keep that going.
It's such a good point. I have this riff about the innovation organizations, which, we love them. There's so many good people who've come through those programs and through those doors. I think at full potential, when we're operating the way we need to, they need to cease to exist. Like what we need to do is change the way that we evaluate performance and the way that we evaluate, these folks in different, whether it's acquisition or program offices. If we're doing our jobs right, we shouldn't need the innovation organizations forever. We kind of catalyzed this moment of change. They were super important. But if they don't fade away, that means we've created this perpetual sideshow of innovation. I hope we're getting closer to that end goal, which actually brings me to maybe one of our final questions here, because we want to be respectful of your time, let you go talk to some of the customers in the building. We talked up front about some of the, the explosion of companies in the autonomy, in the AI space. You've talked about kind of how Applied fits into that ecosystem, but I'm curious, as you think about this, that you just laid out the challenge coming from China. You've laid out kind of where we are on the adoption trajectory, which is we've made progress. There's still a long way to go. How do you see the next couple of years playing out with all of these companies, some at the earliest stages? There's like 7 new maritime autonomy companies. There's a bunch in the air, a bunch on the land, commercial first, defense first, just this big boom of companies who want to solve these problems, which is a great thing. But how do you see this evolving in the years ahead? What happens with all of these companies?
Well, 2 things that the government needs to get really better at if this is actually going to sustain. The first is, again, software. How does the government effectively technically program manage a software contract direct to government? How do they do that? How do they interface between the hardware OEM and, in the case of vehicles and, the software company that they have a direct contract with? So there needs to be some upskilling and or acquisition of talent. And by the way, I sure hope it isn't just hiring another, system integrator to sit in the seat. Look, like there are brilliant people in uniform, and I've worked with them. I talked about them in this conversation. They can actually work a program with multiple logos at a very technical level. You just got to give them the chance. Some of them are operators, some are engineers, some of them are combinations of both. You mentioned Emmy Probasco's, those tri-literate 06s that she talked about, right? Who understood acquisition, technology, and operations. They have to grow those individuals. I think by and large, those are people in uniform more often than not. at least for now, until we can really start to figure out the incentives to get the right civilian talent either upskilled and or integrated into the workforce to do that technical program management piece. You also, honestly, the government needs to figure out how are they going to evaluate like businesses, because look, I love the idea that all these companies are here. Not all of these companies are good businesses. Not all of these companies will turn out to be good businesses. And running an effective business and running a business in a way that is ensuring that you're making the smart decisions from a business sense, the government has to figure out how to evaluate, each of these folks as a business, not just because they have great tech that looks like it's, also, will that business be around? Is that founder really just a 0 to 1 founder, or is that a founder that's going to take them to series B, C, D, et cetera, even public, right? Those are not typically the same people. Those are very different people most of the time. Not all of the time, but most of the time. How does the government know that this is a viable business and it will be a viable business? And what role should the government play in ensuring that these businesses, remain viable? That's a whole different kind of conversation. Should the government be on the board of their, that's obviously kind of a weird thing to propose in some ways. Maybe not,
we'll do a
right?
debate
Like,
next time. We'll get
like In-Q-Tel, there's a model there. There's all kinds of opportunities to really think through that. There's still a lot of work to do. But I think that's exactly what needs to be done, is figure out two things. How do you technically program manage multiple businesses, multiple technologies in a very sophisticated, complex architecture and make it work? Who's the talent that's on the government side that's going to do that? And then the second piece is, how do you know that these businesses are going to be viable if you invest in their tech, and they're going to be viable, 2, 3, 4 years from now? So the warfighter not only receives their capability, but actually will continue to receive it because look, they all want to grow with technology in the sense that obviously the technology advances, but you've got to develop tactics and procedures, and you need to know that that is going to be a consistent tool that you're going to be able to use for a period of time.
Yeah, I think a lot of these companies would say, well, hey, if the government gives me a contract, I'll be viable. It depends how much money they give me, right? It's a
dilemma. It's a dilemma, right? Not to say that they aren't right, but they also have to, make sure that they're being good stewards of taxpayer money, and you've got to find a way to evaluate how well they're functioning.
Yeah, and we heard it, with DevSecOps initially Hicks, and then again yesterday, saying, look, with things like Replicator, we're going to start picking some winners. Which, whether or not you agree with that that frame, I think the idea that okay, the government's gotten better at top of funnel. We've got a lot of folks coming in the front door through as SIBRs, through commercial solutions offerings, what have you. We also have to say, okay, what does it look like when these companies meet the thresholds, they meet our requirements, they perform up to par in our testing and evaluation? How are we prepared to support them into the future? Not just support them, how are we prepared to transition them into capabilities that start to matter at a scale that impacts the mission?
It's a great point. So to be very clear, pick some winners, great. Got to do that. Have an on-ramp. Always when's the next on-ramp? Make sure that's a real on-ramp. It's not just for show.
Yeah.
And then there's also got to be off-ramps. There has to be baking in for all of these technologies, bake in the low switching cost. And design that from the get-go. At any time, that company should feel like they could be replaced by one of these smaller companies who are just killing, right?
Yeah.
They got to feel that pressure.
And I think that's a good thing. So, well, as we let you go here, Jason, one more question just to leave us with. For the folks here today, many of whom, you're in many ways, you're kind of the elder statesman of this movement. I think you've probably been in this before many of these folks knew what defense tech was. Certainly, you've been here longer than I. Whether you're a founder, an operator looking to join a company, an investor who's showed up and has got a bunch of money to plow in, what's the one thing that you would want to leave folks with as they look at the defense tech landscape and think about how they can be most helpful?
It's the most important aspect, the most critical, part of advancing and ensuring our national security that there is. Getting this right, meaning getting emerging technology that is, either, directly, coming from or inspired by what's happening in Silicon Valley, or what has happened in Silicon Valley, in the hands of warfighter. There is no important mission than that when it comes to our national security. no, that's the reason why I took the uniform off and came into this world on this side, right? And will stay in this world for the rest of my career. It is the most important thing. I think all these people, and that's not going to go away. Regardless of bureaucracies, regardless of changes of administration, that's just a fact, right? It's like, at this point, it's like laws of physics. It's just a fact. The reality is that we're going to see others embrace this, others being China and others. We've seen it play out in actual battle in Ukraine. By the way, we didn't even talk about Iran and you know, supplying things to the Houthis, and you know, all of this technology is being democratized.
Yeah.
And so if they can figure it out, if they can cause the kind of, you know, disruption that they have in the last few years, I mean, we have to figure it out. So this is here to stay. You know, there were moments in the past few years I was worried, truly worried. This is here to stay. It's not going away. You just gotta like deal with all the stuff that, you know, that we all complain about, that we covered a number of times in this conversation. It's going to be there. But the cool thing is, like, this community keeps growing, like we talked about. This event is amazing. There's going to be a lot more like it. There's going to be a lot more progress.
As long as there's an America to defend, we're going to have to defend it.
Yeah.
So, Jason,
Indeed.
he's Jason Brown. Company is Applied Intuition. Thank you, sir, for everything
Awesome.
that you
Thanks
do
so much.
and have done. Keep at it.
I appreciate it.
All right.